Have you ever looked at a modern building and wondered how long it will last? 50 years? Maybe a century if it's well maintained? Now imagine standing beneath a dome that has survived almost 2,000 years without steel reinforcement, without modern machinery, and without any of the technology we take for granted today. Even more astonishing, scientists are now discovering that some of these ancient structures weren't just built to last, they were designed to become stronger with time. What researchers have uncovered over the last few years is changing the way engineers think about construction forever. From self-healing concrete to earthquake-proof stone walls. Ancient civilizations may have understood principles that modern science is only beginning to appreciate. And by the end of this video, you'll see why the future of construction might actually depend on lessons from the distant past. Let's begin in the heart of ancient Rome. The Pantheon has stood for nearly 2 millennia, crowned by the largest unreinforced concrete dome ever built. Despite countless earthquakes, storms, and changing climates, it remains remarkably intact. Meanwhile, many modern concrete structures require major repairs after only a few decades. For years, scientists believed Roman builders simply stumbled upon a better recipe. But recent research revealed something much more remarkable. Inside Roman concrete are tiny white fragments that were once dismissed as mixing mistakes. Instead, researchers discovered these pieces were intentionally created through a process known as hot mixing. By combining quicklime directly with other ingredients, the Romans produced highly reactive particles throughout the concrete. Here's where things become extraordinary. When small cracks form over time, rainwater seeps inside and activates those particles. Minerals begin to dissolve, then crystallize again inside the crack, naturally sealing the damage before it can spread. In other words, the concrete repairs itself. Instead of slowly weakening like most modern concrete, some Roman structures possess a built-in mechanism that helps preserve them for centuries. Scientists believe this discovery could inspire a new generation of sustainable construction materials that last far longer while reducing environmental impact. But Rome wasn't the only civilization thinking far ahead. Along Italy's coastline stand ancient harbors and breakwaters that have spent thousands of years battling waves and salt water. Normally, seawater is one of concrete's greatest enemies. It corrodes reinforcement, weakens structures, and shortens their lifespan dramatically. Roman marine concrete behaves very differently. Researchers found that seawater actually triggers the growth of rare minerals deep inside the concrete. Those minerals gradually fill tiny spaces within the material, making it denser and stronger over time. Think about that for a moment. Modern concrete slowly loses the battle against the sea. Roman concrete turns the sea into an ally. Nature wasn't treated as an obstacle. It became part of the engineering itself. And that's only the beginning. Because thousands of kilometers away, another civilization solved a completely different challenge using an ingredient that seems almost impossible to believe: sticky rice. When scientists analyzed the mortar used in parts of the Great Wall of China and other ancient Chinese structures, they discovered that builders intentionally mixed sticky rice with lime. At first glance, it sounds unbelievable, but the rice contains a special starch that creates an exceptionally strong composite material. The mortar became more flexible, more resistant to water, and far better at absorbing stress than ordinary lime mortar. Modern laboratory analysis has revealed just how remarkable this ancient recipe truly was. The sticky rice starch interacted with the lime at a microscopic level, forming a dense network that tightly bonded the mineral particles together. This reduced the number of tiny pores where water could seep in, helping the mortar resist erosion, cracking, and weather damage over centuries. Engineers have also found that this mixture provided an unusual balance of hardness and flexibility, allowing walls to withstand shifting foundations, seasonal temperature changes, and even moderate earthquakes without breaking apart as easily as structures built with conventional mortar. These findings have demonstrated that ancient builders were not simply relying on tradition or trial and error. They had developed a sophisticated construction material whose performance continues to impress scientists studying historic architecture today. This flexibility proved incredibly valuable. As temperatures changed, the ground shifted, an earthquake shook the region. The mortar could absorb movement instead of cracking apart. 2,000 years later, sections of that mortar still hold firmly between the stones. Imagine discovering that one of history's greatest defensive structures owes part of its strength to an everyday food. Now here's where the story takes an even more fascinating turn. If these discoveries surprised you, what scientists found in South America may completely change how you think about engineering. High in the Andes Mountains stands the Inca fortress of Sacsayhuam. Its enormous stone blocks weigh many tons each, yet they fit together with astonishing precision. No mortar, no cement, no glue, just stone against stone. The gaps are so tiny that even a thin blade struggles to slide between them. For centuries, people wondered why the Incas invested so much effort into creating these perfect joints. The answer becomes obvious during earthquakes. Instead of rigidly resisting the shaking, each stone moves independently for a brief moment. The blocks shift, absorb the energy, then settle back into place under their own weight. It's an elegant solution. The walls don't fight the earthquake, they dance with it. Many later colonial buildings nearby suffered repeated earthquake damage over the centuries, yet these much older Inca walls continue standing. Sometimes the strongest design isn't the stiffest one, it's the one that knows when to move. As incredible as that sounds, perhaps the most astonishing ancient achievement wasn't assembled at all. It was carved. In western India stands the Kailasa Temple, an architectural masterpiece unlike almost anything else on Earth. Most buildings are constructed by adding materials together. This one was created by removing them. Ancient craftsmen began with a massive cliff of solid rock and carefully carved downward, revealing an entire temple complex hidden inside the mountain. Columns, staircases, sculptures, halls, and towering gateways all emerged from a single piece of stone. Every cut had to be planned perfectly. There was no second chance. No replacement blocks. No repairs if a mistake was made. Because the entire structure remains connected to the surrounding rock, it contains no construction joints where water can easily penetrate and cause long-term damage. More than 1,000 years later, it still stands as one of humanity's greatest engineering accomplishments. The lesson is remarkable. Sometimes removing material creates something stronger than assembling it. Meanwhile, medieval Europe developed another ingenious approach. Builders wanted enormous cathedrals filled with towering ceilings and massive stained glass windows. The problem was simple. Heavy stone roofs naturally push outward, threatening to collapse the walls supporting them. Their answer became one of history's most recognizable engineering innovations: flying buttresses. Rather than forcing walls to carry every load, these elegant external supports redirected weight safely into the ground. Suddenly, walls could become thinner. Windows could become larger. Cathedrals filled with breathtaking light while remaining structurally stable for centuries. Even the famous gargoyles served a practical purpose. They weren't merely decorations. They channeled rainwater safely away from the building, preventing water damage that could gradually weaken the stone. Beauty and engineering worked together, not against each other. As scientists compare these remarkable achievements across different cultures, one common pattern keeps appearing. The Romans embraced rainwater. Chinese builders enhanced natural materials. The Incas accepted earthquakes instead of resisting them. Indian craftsmen eliminated structural joints. European architects redirected gravity rather than simply fighting it. Different continents, different cultures, different centuries, yet they all reached a surprisingly similar conclusion. The best buildings don't wage war against nature. They work alongside it. That idea couldn't be more relevant today. Modern construction produces enormous carbon emissions, and many buildings are designed with lifespans measured in decades rather than centuries. Technology from the ancient world could help humanity build its future beyond our own planet. Perhaps that's the greatest surprise of all. The most advanced ideas aren't always the newest ones. Sometimes they're simply the oldest ideas we forgot to appreciate. Every ancient monument still standing today carries the same quiet message across the centuries. Great engineering isn't only about strength, it's about understanding the world you're building in. When people designed structures to cooperate with nature instead of overpowering it, they created works that outlived empires, generations, and even entire civilizations. And maybe the next breakthrough won't come from inventing something completely new, but from finally understanding what ancient builders already knew. If this journey changed the way you see the ancient world, let us know in the comments which discovery amazed you the most. Don't forget to like the video, subscribe for more incredible stories where history and science collide, and turn on notifications so you never miss what's waiting in our next adventure.